November 7, 1943, Imperial Japanese Army Ordnance Bureau, Tokyo, Lieutenant General Yoshio Kozuki held the captured American rifle with trembling hands, not from age, but from the realization of what he was witnessing. The M1 Garand semi-automatic rifle had been taken from a dead Marine on Guadalcanal 3 months earlier, shipped to Tokyo, and finally reached his desk for evaluation. He cycled the action. 8 rounds, semi-automatic fire. No manual bolt operation required. The metallic ping as the empty clip ejected echoed through the testing facility like a death knell for Japanese infantry doctrine. Kozuki had commanded infantry battalions in Manchuria. He understood intimately what his soldiers faced with their bolt-action Type 38 Arisaka rifles, weapons designed in 1905 that required manual operation between each shot. Against the Americans and their M1 Garands, Japanese infantry were fighting with technology from the previous century. "How many of these do the Americans have?" he asked the intelligence officer beside him. Major Takeo Imai consulted his report. "Current production exceeds 50,000 monthly, General. By our estimates, they will equip their entire infantry force within 18 months. Kozuki did the mathematics silently. A Marine with an M1 Garand could fire 8 aimed shots in the time a Japanese soldier fired 2. American squads would have 4 to 5 times the sustained firepower of equivalent Japanese units. The implications were catastrophic. What Kozuki didn't know was that his desperate order to create a Japanese copy of the Garand would produce one of the war's greatest engineering failures. The Type 4 rifle, rushed into production in 1944, would jam after 50 rounds in Pacific heat, explode in soldiers' hands, and ultimately prove that superior American metallurgy and manufacturing precision couldn't be replicated by a nation already stretched beyond its industrial capacity. The story of the Type 4 rifle is the story of technological desperation meeting industrial reality, of Japanese engineers attempting the impossible, and of soldiers paying the ultimate price for their nation's inability to match American production quality. The genesis of Japanese infantry's crisis began not in 1943, but in 1936, when the United States Army adopted the M1 Garand as its standard service rifle. Designer John Cantius Garand had solved problems that had plagued semi-automatic rifle development for decades. His gas-operated rotating bolt design was reliable, accurate, and could be mass-produced. The Japanese military had observed this development with concern, but not alarm. In 1936, Japan was fighting in China with bolt-action rifles that worked adequately against similarly equipped opponents. The Type 38 Arisaka, chambered in 6.5mm, was light, accurate, and reliable. Japanese infantry doctrine emphasized marksmanship and discipline over firepower volume. This doctrine would prove fatally flawed against American forces. The first encounter between American M1 Garands and Japanese Type 38 Arisakas occurred on Guadalcanal in August 1942. Japanese infantry, trained in night attacks and bayonet charges, discovered that American Marines could deliver withering sustained fire that shredded their formations before they closed to bayonet range. Corporal Hiroshi Nakamura survived the October 1942 attacks on Henderson Field. His account, recorded by American intelligence after his capture in 1944, provided stark testimony to the firepower disparity. "We charged from the jungle at midnight. The Americans opened fire. Not the slow crack, crack, crack of bolt rifles, but continuous rapid fire like machine guns. Men fell in waves. We never reached their positions. Those who survived crawled back. Of 40 men in my platoon, 8 returned." What Nakamura described was the M1 Garand's combat revelation. American riflemen could maintain sustained, accurate fire without the vulnerability of manually cycling a bolt between shots. Japanese infantry tactics, developed against Chinese forces with similar bolt-action weapons, became suicidal against M1-equipped Marines. By late 1942, Japanese commanders were reporting consistent 3-to-1 casualty ratios favoring American forces in infantry engagements. The M1 Garand wasn't the only factor, but it was significant. Field reports reaching Tokyo described American squads delivering firepower that required Japanese platoons to match. The Imperial Japanese Army faced a crisis that contradicted its entire military philosophy. Japanese doctrine emphasized spiritual strength, discipline, and warrior spirit over material superiority, yet reality was undeniable. Japanese soldiers, no matter how brave or well-trained, were being systematically outgunned. General Kazuki's November 1943 examination of the captured M1 Garand triggered immediate action. He ordered the Technical Bureau of the Imperial Japanese Army to reverse engineer the American rifle and develop a Japanese equivalent. The order came with an impossible timeline: production weapons within 1 year. The engineers assigned to the project understood the magnitude of the challenge. The M1 Garand represented sophisticated engineering far beyond typical Japanese small arms manufacturing. Colonel Kajiro Nambu, Japan's most respected firearms designer, examined the captured rifle and delivered a devastating assessment. This weapon requires manufacturing precision we cannot achieve in wartime production, Nambu told the Ordnance Bureau in December 1943. The gas system alone demands tolerances measured in hundredths of millimeters. The steel quality exceeds our current specifications. The heat treatment processes are more advanced than our industrial capacity permits. Nambu's warnings were ignored. The order came from the highest levels: produce a semi-automatic rifle for Japanese infantry. Imperial headquarters would accept no excuses. The crash program that followed represented Japanese engineering at its most desperate. Unable to directly copy the M1 Garand due to manufacturing limitations, engineers attempted to simplify the design. They studied every component, seeking ways to reduce complexity while maintaining functionality. The gas operating system proved particularly problematic. The M1 Garand used a long-stroke gas piston that required precise gas port drilling and careful metallurgical specifications. Japanese engineers, lacking the manufacturing precision and steel quality of American arsenals, created a simplified short-stroke gas piston system. This modification would prove catastrophic. By March 1944, prototypes of what would become the Type 4 rifle were ready for testing. The weapon externally resembled the M1 Garand, but internally represented significant compromises forced by Japanese manufacturing limitations. Initial testing at the Kokura arsenal revealed problems immediately. Test rifles jammed after sustained firing. The simplified gas system, which worked adequately in controlled conditions, failed when subjected to dirt, moisture, or temperature variations. The rotating bolt, manufactured with inferior steel and looser tolerances than the American original, began showing excessive wear after 500 rounds. Engineers reported these failures to the Ordnance Bureau with recommendations for design modifications and improved manufacturing specifications. The response was brutal: make it work with existing capabilities. There was no time for improvement, no capacity for better materials. Production must begin immediately. In May 1944, the Type 4 rifle entered limited production at the Kokura and Nagoya arsenals. The designation Type 4 referred to the year 2604 in the Japanese imperial calendar, corresponding to 1944 in the Western calendar. From the beginning, production revealed the impossibility of the task. American M1 Garand production at Springfield Armory and Winchester involved precision machinery, quality steel, and rigorous inspection standards. Each rifle underwent extensive testing before acceptance. Japanese Type 4 production operated under desperate wartime conditions. Steel quality was inconsistent as Japan's access to alloying materials diminished. Precision machinery, never abundant, was wearing out without replacement. Skilled workers had been drafted for military service, replaced by inexperienced laborers. Quality control was sacrificed for quantity. The production statistics told the story of Japanese desperation. Springfield Armory alone produced approximately 55,000 M1 Garands monthly by 1944. Winchester added 30,000 monthly. American production exceeded 85,000 semi-automatic rifles monthly from just 2 manufacturers. Japan's entire Type 4 production for 1944 totaled approximately 250 rifles. This wasn't deliberate limitation, but the absolute maximum Japanese industry could achieve, given material shortages, manufacturing limitations, and competing demands from other weapons programs. Even this limited production came at tremendous cost. Each Type 4 rifle required machine hours that could have produced 5 Type 99 bolt-action rifles. The specialized steel needed for gas systems and bolts competed with aircraft engine production. The skilled labor required for assembly was desperately needed elsewhere. Yet production continued because the alternative, admitting defeat in the technological race, was unacceptable to Imperial headquarters. The first Type 4 rifles reached combat units in August 1944. The 14th Division, defending the Philippines, received approximately 50 rifles for field evaluation. What followed was a catastrophe that validated every engineer's warning. Private First Class Kenji Yamamoto was among the first soldiers issued a Type 4 rifle. His account, recorded after his capture on Leyte, provided devastating testimony to the weapon's failures. "They told us this new rifle would equal the American weapons. We were excited. Finally, we would fight on equal terms. The first time I fired it in combat, it worked perfectly. 8 shots, fast and accurate. I felt hope. Then I tried to reload. The magazine wouldn't seat properly. I forced it. The next shot jammed. I cleared it manually. 3 more shots, then another jam. Within 100 rounds, the rifle became useless. The gas system was clogged. The bolt stuck. I threw it away and picked up my old Arisaka from a dead comrade." Yamamoto's experience was universal among Type 4 users. The rifle that worked adequately in temperate Japanese arsenals failed catastrophically in tropical Pacific conditions. The combination of heat, humidity, dirt, and sustained firing exposed every design compromise and manufacturing shortcoming. The technical failures were systematic and predictable. The simplified gas system, designed to reduce manufacturing complexity, lacked adequate venting. Carbon buildup from firing clogged the gas port within 50 rounds. Without proper cleaning, which was impossible under combat conditions, the rifle ceased cycling automatically and became a heavy, awkward, single-shot weapon. The bolt lugs, manufactured from inferior steel with inadequate heat treatment, began failing under the stress of repeated firing. Several rifles exploded when bolt lugs sheared, sending fragments into soldiers' faces. These catastrophic failures killed at least 3 soldiers and injured dozens more. The magazine system, copied from the M1 Garand but manufactured with looser tolerances, frequently failed to feed cartridges properly. Springs, made from substandard steel, lost tension rapidly in tropical heat. Followers bent or jammed. Loading 8 rounds became an exercise in frustration that often failed under combat stress. Most damning was the rifle's accuracy degradation. The barrel steel, lacking proper alloying elements, wore rapidly. After 500 rounds, accuracy decreased noticeably. After 1,000 rounds, the rifle became inaccurate beyond 100 meters, useless for the precise marksmanship Japanese doctrine emphasized. By October 1944, field reports on the Type 4 rifle were universally negative. Division commanders requested the rifles be withdrawn and replaced with standard bolt-action weapons. Several units refused to accept Type 4 rifles, preferring their reliable Arisakas despite the reduced firepower. The Ordnance Bureau's response revealed the desperation of Japan's situation. They acknowledged the problems, but stated that improvements were impossible given material and manufacturing constraints. Units were instructed to use Type 4 rifles only in defensive positions where immediate maintenance was possible. For offensive operations, traditional bolt-action rifles were preferred. This admission that Japan's attempt to match American semi-automatic rifle technology had failed completely never reached the public. Officially, the Type 4 rifle was a successful program. The reality, known to every soldier who fired one, was that it represented Japanese industry's inability to compete with American manufacturing superiority. The contrast with American M1 Garand production and performance was stark and humiliating. By late 1944, the M1 Garand was standard issue throughout the U.S. Army and Marine Corps. Over 4 million would be produced by war's end, each one manufactured to exacting standards that ensured reliability regardless of conditions. American soldiers took their M1s from the frozen mountains of Italy to the tropical jungles of the Pacific. The rifle functioned reliably in temperatures from -30 to +120 degrees Fahrenheit. It operated in mud, sand, rain, and snow. It could fire thousands of rounds before requiring major maintenance. The manufacturing quality ensured this reliability. American steel, properly alloyed with chromium, molybdenum, and vanadium, resisted wear and corrosion. Heat treatment processes, perfected through decades of metallurgical research, produced components with optimal hardness and toughness. Precision manufacturing meant parts were interchangeable between rifles without fitting. Quality control at American arsenals rejected any component failing to meet specifications. Inspectors used precision gauges, measuring to thousandths of an inch. Test firing was mandatory before acceptance. Rifles showing any malfunction were torn down, the defective parts identified and replaced. This attention to quality came at a cost, but America could afford it. The M1 Garand cost approximately $85 to manufacture in 1944, expensive compared to bolt-action rifles, but worth every penny for the tactical advantage it provided. Japan simply couldn't match this manufacturing excellence. The Type 4 rifle, even in its limited production, cost more than 3 times what a bolt-action Type 99 cost to produce. Yet its reliability was orders of magnitude worse. It represented resource expenditure that Japan, with its shrinking empire and diminishing industrial capacity, could not sustain. The human cost of the Type 4 failure extended beyond soldiers killed by exploding rifles or murdered because their weapons jammed in combat. It represented the lost hope of Japanese infantry who believed they would finally receive weapons matching American firepower. Sergeant Takashi Ito commanded a rifle squad on Iwo Jima in February 1945. His unit had received 6 Type 4 rifles in December 1944. By the time of the American invasion, all 6 had been abandoned as useless, replaced by standard Arisakas. The new rifles were worse than having nothing, Ito said in a 1976 interview. They gave false hope. Men believed they could match American firepower. When the rifles failed, as they always did, the psychological impact was devastating. Better to know your limitations and plan accordingly than to expect capability that doesn't exist. The engineering lessons from the Type 4 failure were lost in the chaos of Japan's collapsing war effort. Had there been time for analysis, Japanese engineers might have understood several crucial truths about the technological gap they faced. First, the M1 Garand wasn't just a good design, it was a design optimized for American mass production capabilities. John Garand had spent years refining his rifle specifically to work with American manufacturing methods and materials. The tolerances weren't arbitrary but precisely calculated to work with American steel quality and heat treatment processes. Second, semi-automatic rifle reliability required systematic excellence across the entire manufacturing chain. Superior design meant nothing if steel quality varied, if heat treatment was inconsistent, if dimensional tolerances weren't maintained, or if assembly wasn't precise. The M1 Garand succeeded because American industry excelled at all these factors simultaneously. Third, and most importantly, technological capability couldn't be wished into existence. Japan's industrial capacity in 1944 couldn't produce M1 Garand equivalent rifles regardless of engineering skill or worker dedication. The necessary precision machinery didn't exist. The steel quality couldn't be achieved with available alloying elements. The manufacturing knowledge built over decades in American arsenals couldn't be acquired in months. The Type 4 rifle's failure demonstrated a broader truth about the Pacific War. By 1944, Japan was fighting an opponent whose industrial and technological superiority made defeat inevitable. The M1 Garand was just one example of this disparity, but it was telling. In the most fundamental infantry weapon, the rifle, Japan couldn't match American capability despite desperate efforts. General Douglas MacArthur, reviewing intelligence reports on Japanese equipment in December 1944, noted the Type 4 program in his personal papers. His comment was succinct: that the enemy attempted to copy our M1 and failed so completely indicates their industrial situation is dire. They lack the capacity to compete with our production quality. American intelligence carefully studied the few Type 4 rifles captured in combat. The technical reports, preserved in the National Archives, revealed American analysts' assessment that the Type 4 represented a gallant but futile attempt to achieve technological parity through improvisation and adaptation under extreme resource constraints. One analyst's comment was particularly insightful. The Type 4 failure isn't an engineering failure. Japanese engineers clearly understood the M1's principles. It's a manufacturing failure, revealing the vast gulf between American and Japanese industrial capacity. They simply cannot build to the precision and quality standards our weapons require. By early 1945, Type 4 production had effectively ceased. The official reason was reallocation of resources to more critical weapons programs. The reality was acknowledgement of failure. Japan stopped producing a weapon that didn't work, cost too much, and provided no advantage over simpler bolt-action rifles that, while inferior to American semi-automatics, at least functioned reliably. The final production total remains debated among historians. Most estimates suggest between 250 and 300 Type 4 rifles were manufactured. Some sources claim up to 500, but documentation is sparse. What's undisputed is that the program was a complete failure measured against its objectives. The intended goal of equipping Japanese infantry with semi-automatic rifles, comparable to the M1 Garand, was never remotely achieved. A few hundred rifles, most of which quickly became inoperable, had zero impact on the tactical situation Japanese forces faced. For Japanese soldiers fighting in the Pacific's final year, the Type 4's failure meant continuing to face American forces with bolt-action rifles designed 40 years earlier. They watched American Marines and soldiers deliver rapid, accurate fire while they manually cycled bolts between shots. They experienced the terror of American assaults where every attacking soldier could fire 8 aimed rounds in seconds, while Japanese defenders fired slowly, methodically, and died quickly. The few Type 4 rifles that survived the war became historical curiosities, museum pieces representing Japanese desperation and industrial inadequacy. Collectors prize them for their rarity, but their value is historical rather than functional. Most examples show evidence of the failures that plagued them: cracked bolts, eroded gas ports, broken magazines, bent followers. The Japanese government never officially acknowledged the Type 4's failure. Post-war publications mentioned it briefly as a limited production semi-automatic rifle, without elaborating on its catastrophic unreliability. Veterans who used them knew the truth but rarely spoke of it, another shameful memory in a war filled with shame. The broader lesson of the Type 4 program extended far beyond one failed weapon. It revealed the fundamental disparity between American and Japanese industrial capacity that made Japan's defeat inevitable, regardless of tactical brilliance or fighting spirit. Consider the mathematics of the manufacturing gap. By 1944, American industry was producing approximately 1,000 military aircraft monthly, 2,000 tanks monthly, hundreds of ships annually, millions of rifles and machine guns, billions of rounds of ammunition, all while maintaining civilian production that exceeded Japan's entire pre-war industrial output. Japan's industry, strangled by submarine blockade, devastated by strategic bombing, stripped of skilled workers, starved of raw materials, was producing fractions of these quantities at quality levels that continually degraded. The Type 4 rifle was just one example of this collapse, but it was telling precisely because rifles were relatively simple weapons compared to aircraft or ships. If Japan couldn't manufacture reliable copies of American rifles, how could it hope to compete in aircraft, ships, electronics, or any other technology-intensive category? The answer, obvious by 1944, but unacceptable to Japanese leadership, was that it couldn't. American superiority wasn't just in design or in production volume. It was in the systematic excellence that produced M1 Garands that functioned flawlessly through thousands of rounds, in conditions from Arctic cold to tropical heat, that could be repaired in the field with minimal tools, that were so reliable that soldiers trusted their lives to them without hesitation. This reliability came from manufacturing systems Japan couldn't replicate. Standardized processes, quality control, precision machinery, skilled workers, and above all, abundant resources of the right quality. American steel plants could produce whatever alloys weapons required. American machine tool industry could manufacture precision equipment. American technical schools produced skilled workers in unlimited quantities. Japan had none of these advantages by 1944. The Type 4 rifle's failure was inevitable, not from lack of effort or skill, but from attempting the impossible under intolerable constraints. The soldiers who received Type 4 rifles and watched them fail understood this implicitly. The weapon's unreliability wasn't a surprise, but confirmation of what they already knew. Japan was losing the industrial war, and all the fighting spirit in the world couldn't compensate for material inferiority. Private Yamamoto, whose account of the Type 4's failures was quoted earlier, survived the war and lived until 1993. In his memoirs, published in Japan in 1985, he reflected on his experience with the failed rifle. The Type 4 represented our nation's desperation and our industry's limitations. We wanted to believe we could match American technology, but reality was cruel. The rifle that jammed in my hands at Leyte was my first understanding that we could not win this war. If we couldn't build a working rifle, how could we defeat a nation that built thousands of ships and tens of thousands of aircraft? This realization, spreading through the Japanese military as soldiers encountered failure after failure of weapons and equipment, contributed to the collapse of morale that characterized Japan's final year of war. The Type 4 rifle was a small part of this story, but its impact on individual soldiers who needed weapons they could trust was profound and demoralizing. For American forces, Japanese failure to field effective semi-automatic rifles provided significant tactical advantages that persisted throughout the war. Marine and Army rifle squads could deliver firepower that Japanese units couldn't match. This advantage was greatest in the close-range jungle fighting that characterized much Pacific combat. In these engagements, the ability to fire rapidly without manually cycling a bolt between shots often meant the difference between survival and death. American infantrymen could maintain fire superiority that suppressed Japanese positions while maneuvering. Japanese infantry, limited by bolt-action rifles, struggled to deliver enough fire to stop American attacks. Casualty statistics reflected this firepower disparity. In rifle engagements where forces were roughly equal, American units consistently inflicted higher casualties while suffering lower losses. The M1 Garand wasn't the only factor, but it was significant. Studies conducted by the U.S. Army after the war concluded that the M1 increased American infantry effectiveness by approximately 30 to 40% compared to bolt-action-equipped forces. This advantage, multiplied across hundreds of engagements over 3 years of Pacific fighting, contributed substantially to American victory. The Japanese inability to match this advantage through the Type 4 program or any other means ensured that their infantry remained at a permanent disadvantage. The story of the Type 4 rifle concludes not with battlefield glory or technical triumph, but with quiet cancellation and historical obscurity. By summer 1945, as Japan prepared for the expected American invasion, no Type 4 rifles remained in frontline service. Those manufactured had been withdrawn, scrapped, or abandoned. Japanese infantry faced the war's end with the same bolt-action rifles they'd carried since the 1930s. This failure, combined with failures in aircraft, naval vessels, tanks, and virtually every category of military equipment, ensured Japanese defeat. The atomic bombs dropped on Hiroshima and Nagasaki in August 1945 ended the war before American invasion became necessary. Had that invasion occurred, Japanese infantry with their bolt-action rifles would have faced American forces with M1 Garands, automatic rifles, and overwhelming firepower superiority. The outcome would have been massacre. The Type 4's failure perhaps spared its intended users from deaths that might have resulted had they trusted the unreliable weapon in that final battle. Small mercy, perhaps, but in war, soldiers take what mercy they can find. Today, the Type 4 rifle exists primarily in museums and private collections, a footnote to the Pacific War. Historians recognize it as an example of Japanese industrial desperation and technological inadequacy. Engineers study it as a cautionary tale about attempting to replicate advanced technology without the manufacturing infrastructure to support it. For students of military history, the Type 4 represents a broader lesson about industrial warfare. In conflicts between industrialized nations, manufacturing capacity and quality often matter more than tactical brilliance or fighting spirit. Japan's soldiers were brave, well-trained, and dedicated. But they were equipped with weapons their industry couldn't produce to competitive standards, and no amount of courage could overcome that material disadvantage. The M1 Garand continued service long after World War II. It was the standard American rifle through the Korean War, where it again proved superior to opponents' weapons. Not until the adoption of the M14 in 1957 and then the M16 in the 1960s did the US military move beyond Garand's design. Even then, the M1 remained in reserve use and with allied nations for decades. This longevity testified to the excellence of the original design and American manufacturing quality. A weapon designed in the 1930s remained competitive into the 1960s because it had been designed right and built right from the beginning. Japanese attempts to copy it in 1944 under impossible conditions were doomed before they began. General Kozuki, who had examined that first captured M1 Garand in November 1943 and triggered the Type 4 program, survived the war. In the 1950s, working for Japan's reconstructed self-defense forces, he was asked about the wartime program to develop semi-automatic rifles. His response, recorded in a 1955 interview, reflected hard-learned wisdom. "We attempted something impossible. The Americans had decades of industrial development, abundant resources, skilled workers, and precision manufacturing capability. We had none of these. We thought Japanese spirit and engineering cleverness could overcome material limitations. We were wrong. The Type 4 rifle's failure taught me that in modern war, industrial capacity determines victory more than tactical doctrine or fighting spirit. It was a lesson we paid for in blood." That lesson, learned through the failure of the Type 4 and countless other technological programs, shaped post-war Japan's approach to industrial development. The same nation that couldn't build reliable semi-automatic rifles in 1944 became, within 3 decades, a global leader in precision manufacturing and quality control. The transformation was remarkable, built on lessons learned through wartime failure, but in 1944 and 1945, as Japanese soldiers fought and died with bolt-action rifles against M1 Garand-equipped American forces, that future transformation provided no comfort. They faced immediate reality. Their nation's industry could not equip them adequately, and their brave resistance could only delay inevitable defeat. The Type 4 rifle, jamming after 50 rounds in Pacific heat, exploding in soldiers' hands, abandoned as useless on battlefields across the Pacific, stands as monument to this reality. It represents not engineering failure, but the collision between desperation and impossibility, between what Japan needed and what Japan could provide, between hope and reality. In the end, the Type 4's story is tragedy, not of design or manufacturing mistakes, but of a nation attempting to fight an industrial war it could not win, making desperate attempts to close technological gaps that were unbridgeable given its circumstances. The soldiers who received Type 4 rifles, trusted them, and watched them fail, paid the price for their nation's impossible position. They deserved better weapons. They deserved reliable equipment. They deserved a chance to fight on equal terms. Instead, they received rifles that jammed after 50 rounds, manufactured by an industry that lacked the capacity to produce weapons matching their opponents, fighting for a nation whose defeat was ensured by the very industrial inadequacy the Type 4 represented. That is the true story of Japan's Type 4 rifle, a desperate attempt to copy American excellence, a catastrophic failure that revealed unbridgeable gaps in industrial capacity, and a weapon that promised much, delivered nothing, and stands forever as testimony to the futility of Japan's Pacific War.